Hey guys, this is Mrs. Keith, and this is the lesson over the algebra review for our first lesson this marking period. We're going to start off by talking about domain. So you remember domain is the x values, or that's the way most of us kind of think through it, but we want to think of it as the set of values that a variable may assume, and that's what is called the domain of the variable. There are some special functions where the domain is restricted, however. So remember back last year when we talked about a square root function, that graph looked something like this. And the equation would have been f of x equals the square root of x. So basically what I want you to notice that you only have the x values that are on the right-hand side, or the positive x values from the origin. You don't have any negative x values. So our domain is going to be x is greater than or equal to 0. These are numbers that you can easily take the square root of without getting an imaginary number. That's one way to write it. Another way to write it is using interval notation, where you would say bracket and then you go 0 to infinity. We use the bracket because it can include 0. A rational function, when you graphed it, it looks something like this. The equation was f of x equals 1 over x. And right here, where x is in the denominator, that caused a problem. That made us have an asymptote right here on the y-axis. And so that means that we can't divide by 0. And so that's whatever makes that denominator 0, that should be excluded. So to exclude that, a lot of times we just say all real numbers and x cannot equal 0. Or we write it like in interval notation, negative infinity to 0, with the parentheses because we don't want to include the 0, and then union 0 to infinity. That way, this excludes this 0 right here from all real numbers. Okay, then one more function that we encountered last year in Algebra 2 was the log function. And if you'll recall, the graph looks like this, and the equation looked like this. And remember, when you take the log of a number, you have this asymptote right here again on the y-axis. You can't take the log of 0 or any negative number. So this time, the domain should be x is greater than 0. Oh, whoops, I did that wrong, sorry. X is greater than 0, or in interval notation, you would say 0 to infinity, making sure you use parentheses this time because it's not included. So making sure you know the domain of each of these functions is pretty important. So these examples below are using these types of functions. This one is a rational function, and we know that it is because x is in the denominator. So what we care about is what makes that denominator equal to 0. It can't equal 0, so we want to know what makes it equal to 0. So if I solve this for x, I would move this 7 over by adding it, and then divide by 3, and I get 7/3. Well, that's the number that x cannot equal, because if it does, it makes your denominator 0. So we can write it in interval notation by saying negative infinity to 7/3, and then union 7/3 to infinity. So basically that's saying all real numbers except for x cannot equal 7/3. On the next one, we have a square root function. And so we talked about how whatever's underneath this radical, it has to be greater than or equal to 0. So x plus 4 has to be greater than or equal to 0. So we're going to, and if you think about the graph of that, that's the square root function that's been shifted to the left 4, so it looks like this. So all the x's should be greater than or equal to negative 4. When you move that 4 over, you subtract it, so it's x is greater than or equal to negative 4. Or you can write it like this. You can say bracket, because we can include the negative 4 all the way to infinity. All right, the log function. Remember the log function. This one has been shifted to the right 9. So now that you have an asymptote right there at 9 and your graph looks like this, you can't take the log of 0 or a negative number. So x minus 9 has to be greater than or equal to 0. Solving that for x, we get x is greater than or equal to 9, which matches what our graph has here. We can, oh my goodness, I did that wrong again. I'm sorry. Let me rewrite that. Sorry, guys. X minus 9 has to be greater than 0. It cannot equal 0. So x is greater than 9. That's one way to write it, or you could say 9 to infinity. Sorry about that. All right, that's the domain for those three examples. All right, let's move on to the law of exponents. Okay, remembering our rules for exponents, I like to use the order of operations to help me remember my rules for exponents. So if you're an exponent, and let's say we're doing an operation like we're raising a power to a power, we're raising an exponent to an exponent, where our exponents are baby numbers. They can't quite do that operation. They do one step less. So right here we have, for example, on this first one, we're using the product rule for this one. The product rule means that you're doing multiplication, and so your exponents do one step less, and they're going to add. So that's what they're saying here, when you have a to the m times a to the n equals, that's the same thing as that same, we've got the same base, so you write that base, and then you add their exponents. So in this example over here, we've got the same base of 3, so I'm going to write that 3, and then because I'm multiplying them, I'm going to add their exponents. And then you can just combine those like terms. So you end up with 3, I am running out of room. I'm going to write it up here. Sorry, guys. So that's 3, and then that's raised to the 3x minus 4. All right, on the next one, the quotient rule. Now we're doing division. So we're on this level right here of our order of operations, which means our exponents are going to do one step less, and they're going to subtract. So as long as you have the same base, which we do, we have a base of 2, we can subtract those exponents because our operations division, this line right here means division. So 5x minus 3x gives me 2 to the 2x. You also need to remember that you're not supposed to have a negative exponent. So anytime you have a negative exponent, just rewrite it like you write it where it changes its place in the fraction, and then it has a positive exponent. So in this case, we could rewrite it as 1 over 5 to the positive 2, or 1/25. On the next one, we're doing the power rules. So now we're raising an exponent to a power. And basically, you just need to think about distributing that, because if you're on this level for right here for exponent, your exponents will do one step less, which is multiply. So here, I'm going to distribute that 3 to both of those exponents, so that becomes 4 to the 6th over 5 to the 6th. Another way to write that would be 4 over 5 to the 6th power. Or you could actually calculate what it is as well. Probably something that big, we wouldn't make you do that in your head. I guess it's possible with a calculator, but so this one's another example. We have 3 and raised to the x plus 7. It's raised to the 4th power. So distribute that 4. That'll be 3 to the 4x plus 28. On the next one, it's reminding you that when you have a fractional exponent, the denominator is the root and the numerator is raising it to a power. So here we've got x plus 5, and it's raised to the 3/4 power. So we can rewrite it like that. And then one more rule is to remember that anytime you have an exponent of 0, anything raised to the 0 power is just 1. So if I were going to simplify this next one, I would group my numbers together. So 15 over 3. I've got x to the 0. And then you've got the same base of y. Because it's being divided here, you're going to subtract those exponents. So that simplifies to be 5. X to the 0 is just 1. And then that becomes y to the 1st power. So this is the same thing as 5y. All right, that's our exponent rules. All right, now we're going to remember how to do factoring. If we've got a quadratic function, that means that we have an x squared. We usually write it in standard form like this, and if we're going to solve it, we want it equal to 0. Well, you have to be told that it's equal to 0. You can't just randomly put that it's equal to 0, but usually when we solve it, it's equal to 0, and that's what it has to be. So your a is always the number in front of x squared, your b is the number in front of x, and then c is just your constant at the end. So we have 3 different ways, or 3 special ways of factoring. There's various ways to just do this trinomial. You can do it basic guess and check, or there's the grouping method, there's the box method, or there's slide and divide. that's how to do a normal trinomial. These are special though. These are when you've got two terms. Oh, another thing to always remember is to make sure you get the greatest common factor first, if there is one. All right, these next examples though, or things in our notes, are telling us how to do some special ones. When you just have two terms and they're separated by a minus sign and both of those terms are squared, we call that the difference of squares. So it always factors. You take that first term. Let me erase some of that so it's not everywhere. You take that first term and you take the square root of it, you get a, so that a goes here and here in your parentheses. You take the second term and you take the square root of it, and we get b here. That's what goes here and here in your parentheses. And then you end up with a minus and a plus in those parentheses, so that's the way that's going to factor. So let's say we have something like, let's see, how about, I don't know, 121x squared minus 49y squared. So I would take the square root, it's a difference of squares, both of those terms are squared and it's separated by a minus sign. So I'm going to take the square root of 121x squared and I get 11x. And then if I take the square root of 49y squared, I get 7y. So this is going to factor to be 11x plus 7y and 11x, oops, let me rewrite that, sorry. 11x minus 7y. Did not write that very well, sorry. 11x plus 7y and 11x minus 7y. So that's how that would factor as a difference of squares. All right, I'm going to erase all of that just to give myself room again. All right, another option that you might have is sum or difference of cubes. So again, you either have a minus or a plus, so difference or sum, and both of the terms on either side of it is a perfect cube. Well, it's always going to factor to be a binomial times a trinomial. And then we use the acronym SOAP to help us get the signs that go between each of the terms. So in this example right here, this is the same sign, this is opposite, and this is always positive. And then how you get those numbers in the trinomial, both the binomial and the trinomial. Let's just do an example. Let's say I have, I don't know, x cubed minus 8. Those are two terms separated by a minus sign. They are both perfect cubes, so I'm going to take the cube root of x cubed to get x. The cube root of 8 is 2. So when I factor this, I'm going to have a binomial times a trinomial. So when I put my terms in the binomial, I just take, those cube roots right there, the x and the 2, and I have to worry about my signs separating them, and I'm using SOAP. So this is going to be the same sign, so minus, because that's what we have over here. And then over here, I'm going to have opposite sign and always positive. So then how you get these, this is all opposite and always positive. How you get what goes in the trinomial is you take this first term, the x, and you square it. It goes here. You take the second term, the 2, and you square it, and that goes over here on the end. And then this middle term will be those two terms in that binomial multiplied together. So x times 2 is just 2x. And you don't worry about the negative because your signs come from this SOAP thing. So this is the fully factored form of that difference of cubes. All right, one more that you might encounter is called a perfect square trinomial. If you notice, we've got a plus b squared. So that means we're multiplying a plus b times a plus b. And you could go ahead and multiply it all the way out by distributing the a through that parentheses, and you get a squared plus ab. Then just distribute the b, so you get ab again. I always write them alphabetically, plus b squared. And then that simplifies, when you combine these like terms right here, it simplifies to look like this. So when you have a perfect square trinomial, basically you have your first term is squared to get you this, your last term is squared to get you this, and then your middle term multiplies that a and b together and then doubles it. So let's say you had something like, I don't know, x plus 8 squared. It's going to multiply to be x squared here, and 8 squared is going to be in the end. The middle term will be these two multiplied together and then doubled, so that's 16x. Everything's positive here because of that plus right there. So this is how this one would multiply out. Now if you had a minus right here, the only thing that will change is that there will be a minus there. All right, that's just a way to help you kind of work things faster when you think of it as a perfect square trinomial. You can do it another way, but that makes it a little bit faster. All right, let's do some examples of these. I'm going to pause. Okay, in this first example, looking at this, the first thing we should notice that there is a greatest common factor. Each of these three terms have a 3 in common, so I'm going to pull it out as a greatest common factor. And remember, when you pull out a greatest common factor, you're dividing each term by that greatest common factor. So 3x squared divided by that 3 gives me x squared. 9x divided by that 3 gives me 3x. And negative 30 divided by that 3 gives me a negative 10. All right, a lot of you use the big X method or whatever. You multiply your x squared and your negative 10, and you get negative 10x squared. And then your middle term is that 3x. So we're looking for two things that multiply to give me the negative 10x squared, and two things that add to give me the 3x. So what I would choose is a positive 5x and a negative 2x, because they multiply to be negative 10x squared and they add to be 3x. And then what I'm going to do is replace that 3x with those two terms. So that's going to be 3 times x squared plus 5x minus 2x minus 10. And then I'm going to use the grouping method to continue factoring that. So I'm going to group the first two. This 3 is just on the outside. I'm going to put a bracket here. I'm going to group the first two, and I'm going to group the last two. And what those first two have in common is an x. And when I pull that out like a greatest common factor, I'm left with x plus 5. Then I bring down this sign, which is a minus, factor out what those two have in common, which is a 2. And when I pull out that negative 2 from the 2x and the negative 10, I end up with x plus 5 again. So now we've got two terms, and those two terms have x plus 5 in common. So that will leave me with 3 times that x plus 5, which is the greatest common factor between those two terms, and then I'm left with x minus 2. So this is the fully factored form of that. A lot of you can go straight to this form on this one, because right here you had just a plain old x squared. So that one's pretty easy to just go straight into this last the answer there. I just wanted to show you the grouping along the way if you needed it. All right, on the next one, you've got three terms. Terms are always separated by pluses and minuses. So you've got three terms, and all three of those terms have something in common. What they have in common is that y plus 7 squared. They all have at least a y plus 7 squared. So that's my GCF. When I pull that out of the first term, I'm left with another y plus 7 squared. When I pull it out of the second term, I'm left with 11 times y plus 7 to the first power. And when I pull it out of the last term, I'm left with the positive 30. All right, now that I'm going to multiply, I'm going to keep working on this to simplify it. I'm going to multiply that out inside of here, inside the bracket there. Y plus 7 squared, when you multiply it out, that's a perfect squared trinomial. So that's going to multiply out to be y squared, plus that middle term will be the 7 and the y multiplied together and then doubled. So that's 14y plus 49. Distribute the negative 11, so we get a negative 11y minus 77 plus 30. And then I've got y plus 7 squared. Simplifying inside of here, I end up with y squared, 14y and a negative 11y. Those combine to be 3y. And then when I combine the 49, the negative 77, and the 30, I get a positive 2, which that will factor further as well. So that gives me y plus 7 squared, and then this is going to factor to be y plus 2 times y plus 1. And that is your fully factored form for that. All right, on the next one on letter C, we have a difference of squares. That minus sign tells me difference, and then both of those terms are perfect squares. So if I take the square root of 9x squared, I get 3x. If I take the square root of 25, I get 5. And then when I factor, I'm going to have two binomials. They're going to have the same thing in both binomial. And then one gets plus and one gets a minus. So that one is factored. This one I know is a perfect square trinomial because it's, you know, like we were doing up here with the perfect square trinomial. I know that it is because if I take the square root of that x to the 6th, I get x cubed. If I take the square root of 729, I get 27. And when I multiply x cubed times 27 and then double it, I get this 54x cubed. So that's going to factor to be x to the 3rd minus 27, the quantity squared. Now this is a difference of cubes, so it's going to factor further. Remember, it factors, and I'm going to rewrite this. This can be rewritten as x cubed minus 27 times x cubed minus 27 because it's squared. So if we factor this, it's a difference of cubes. You take the cube root, you know, you're using that SOAP. Oops, sorry. You're using SOAP. So you have a binomial. Oops, sorry. You have a binomial times a trinomial. Take the cube root of x cubed and get x. That goes here. The cube root of that 27, which is 3, it goes here. You square the first term, it goes here. You square the last term, it goes here. The middle term is those two terms, the 3 and the x, multiplied together. And then you use SOAP to get your signs. So this is the same sign, this is opposite, this is always positive. So that's what the first one will factor to be. And then do it one more time for the other one. It'll be the same. And so we could rewrite it as x minus 3 squared times x squared plus 3x plus 9 squared. And then that's fully factored. All right, so that's our notes for today. Thanks, y'all.